So I'm going to start with a brief introduction for each of our panelists here. And we've got 3 here and 1 online. Al, I can see you on the monitor in front of us. We'll get you up on the big screen here in just a moment. And then we have a guest panelist that we haven't announced yet, so I'll introduce that in a little bit. But I'll start with John Stogowski at the end, who's a senior engineer at Carnegie Mellon Software Engineering Institute. He's had a number of roles there at CERT and AI divisions. He's currently working with DoD sponsors to research how artificial intelligence can be applied to increase capabilities and build the AI engineering discipline. Previously, he oversaw a prototyping lab focused on evaluating emerging technologies and designed patterns for addressing cybersecurity operations at scale. Before SEI, John had a career at a major telecommunications company where he was a director of things like the Security Operations Center and the Homeland Security Office, established after 9/11 attacks. John believes that the lessons we learned from maturing the security field can be merged with the unique aspects of AI to enhance system development lifecycle and realize opportunities to increase our strategic advantage. Online, we have Dr. Alec Banks joining us from the UK today. He's a senior principal scientist at the Defense Science and Technology Lab, DSTL, for the UK. He's worked in defense engineering for over 30 years and spells defense properly with a C. His research work is focused on the safety of software systems, including working as a software regulator for the UK air platforms and developing software safety assurance for the UK's next-generation submarines. In his regulatory capacity, he's provided software certification assurance for platforms such as ScanEagle, Watchkeeper, and F-35 Lightning II. More recently, Alec has been MOD lead on research and test evaluation, verification, and validation of autonomy and AI-based systems. This has included revisions of the UK Defence Standard for software safety to facilitate greater use of models and simulations, and the adoption of machine learning in higher integrity applications. Thank you for joining us, Al. Next to me here, we have Dr. Laura Freeman, who's a research associate professor of statistics and the deputy director for the Virginia Tech National Security Institute. Her research leverages experimental methods for conducting research that brings together cyber-physical systems, data science, artificial intelligence, and machine learning to address critical challenges in national security. She's also a hub faculty member in the Commonwealth Cyber Initiative, I can't say Commonwealth, and leads research in AI assurance, and is developing new methods for test and evaluation focusing on emerging system technology. She's also the Assistant Dean for Research for the College of Science, and in that capacity works to shape research directions and collaborations for the College of Science. Previously, Dr. Freeman was the Assistant Director of the Operational Evaluation Division here at IDA. And at this point in her bio, it says something about establishing an interdisciplinary team of statisticians, psychologists, and engineers, but I notice you don't say that you started DataWorks. And Bram thanked you earlier for that, but thank you again for kicking this off in 2016 and giving us the foundation to be here today. And then in the middle, joining us from the newest UARC, there's the second newest UARC. Dr. Joshua Poore is an associate research scientist with the Applied Research Laboratory for Intelligence and Security, ARLIS, at the University of Maryland. He supports the AI Autonomy and Augmentation, AAA, mission area. Previously, he was a principal senior scientist and technology development manager at BAE Systems, FAST Labs, and principal scientist at Draper. Dr. Poore is interested in measuring human performance using ubiquitous software and distributed IT and information architecture for reasoning about human system integration in and across systems. Currently, this work serves as ARLIS's AAA testbed for test and evaluation activities. He also leads the development of open source technology as a committer and project manager committee member for the Apache Software Foundation. Random things in your bio. So thank you. That was, hopefully that's the rest of what you're going to hear me talking because we brought them here. So I'm going to start off with a couple questions. While I'm asking some questions, please start preparing yours because the intent here is that we're going to pepper them with questions about AI assurance. I tried to make this panel about AI assurance cases, but I realized that nobody heard cases. So we've come here to talk about AI assurance, and I'll try and pull a little bit of a thread on AI assurance cases occasionally. Oh, I forgot our guest panel member. Could you go to my laptop screen, please? I brought ChatGPT with us. So ChatGPT, would you write a short introduction for yourself for a panel on AI assurance? I really appreciate that it's slowing down the typing to.
It's got tested in there. Very
Excellent.
front and center.
All right, so please also, as you're thinking of questions, feel free to pose questions to ChatGPT, and we'll come back to my screen as needed. So let me start off. Laura, I understand that you're editor of a book that just came out on AI assurance and several recent papers, and I tried to pull this panel together on AI assurance cases, but since that got dropped, would you describe what AI assurance is to us and maybe briefly touch on what an assurance case is and how we would apply it to AI?
Sure. Thanks for the opening question on one of my favorite topics outside of experimental design, which I will factor in somehow into this definition. So I want to start with just the definition of assurance, starting with the English language. And if you go Google assurance and look for the definition, you'll come up with one of the alternate definitions is to have confidence in one's ability. And so very simply, AI assurance is just to have confidence in the AI's ability in my mind. But we can also build on lots of other types of assurance. Information assurance, software assurance, quality assurance have all been defined terms and techniques that we've used over the years. And what they've really layered on to that confidence element is, when you look at software assurance, operate as intended, free from vulnerabilities. So it's adding criteria, right? Free from vulnerabilities. Info assurance defines confidentiality, integrity, and availability as key characteristics for information assurance. And then as a statistician, especially an industrial trained statistician, my favorite is quality assurance, because there you're starting to get into really stochastic processes as well. And what quality assurance introduces for us is the systematic processes at every stage of the life cycle. And so we're getting to more of it's not just about having confidence across certain characteristics, it's doing it through systematic processes across the life cycle of systems. And so you put all those together and you think about the things that we're talking about for AI assurance, properties like bias, fairness, explainability, trustworthiness, safety. Those are the characteristics that we care about in addition to, operating as intended, free from vulnerabilities. But the important piece here, and where I think test and evaluation comes in, is those systematic processes, starting from the model itself all the way into its employment in a system and then into an operation. What are those systematic processes that build the body of evidence that give us that confidence? That's what we need to be thinking about for AI assurance. And so I was giving Chad a hard time because I'm not a fan necessarily of the concept of insurance cases, and so I want to explain why. So what an assurance case is really is the structured claims and arguments supported by evidence which gives the confidence. And so the reason that I struggle with the term is because cases to me is countable, right? Like how many cases do I need? And I think any good tester knows that there is no one right test approach. And it's about the learning process that we go through. It's not things that you can count off necessarily. And as you go through a test process, you're going to learn new things. And so while I think that's a very good definition for assurance cases, I want to really emphasize the structured process and that test and evaluation, and having a learning mentality in test and evaluation is how we're going to build our AI assurance story and get that body of evidence.
Thank you, Laura. Al, we're going to go out to you with this question. And I know that you've seen and done a number of assurance cases for real systems. So I'm going to ask you something about them, but I also would love to have your response to Laura's concern about assurance cases as a countable thing that limits or constrains us in developing AI assurance. But the question for you are, what are some of the pitfalls and traps that you've seen in the assurance cases that you've been involved with?
Yeah, okay. Can everybody hear me okay? I've not done a comms check this morning.
Loud and clear.
Okay, excellent. Thank you. So absolutely. Something that has an assurance case, whether it be a safety case or any other type of case, is not necessarily safe, right? So that's the key thing for everybody to remember, is that just because somebody comes to you and says, I've got this assurance case, it doesn't necessarily mean that you know how much confidence you can have in the system. And that brings me to my first point, about what can go wrong with safety cases or assurance cases, and that is how you communicate the level of risk that is in the system still. So just because you have a safety case doesn't mean it's 100% safe. I always say to people, Yeah, so if you want a safe system, the only safe system you can have is one that you leave in the garage, right? And then somebody said, yeah, but my garage could catch fire. So even that one went out the window. So so the first challenge is how do we communicate the extant risk to the person who's making the decision based on the assurance case? And now going back to the kind of the previous point about, you know, the challenge with an assurance case, I take people to a legal case. So assurance case of legal cases that they make in courts. And the idea behind a legal case that they make in courts is one person puts their case forward, and then the prosecution might put their case forward, and then the defense might counter that and try to undermine each other's case. And that's what we should be doing with assurance cases. And that brings me to my kind of next point of the problems with assurance cases, and that is overconfidence and confirmation bias. And what we really should be doing is we should be looking at the cases that we put together, looking at how well they're structured, and then try to undermine our own safety cases. Get somebody who's independent to come in and look at it and try to implement case arguments that will undermine the safety case that you're putting forward. And that's not done anywhere near enough. So I'm not sure how much time I've got, Chad, by the way, so please do tell me to stop rabbiting. Some of the real live kind of issues that we've had with safety cases is where people have, for example, misinterpreted things. And I'll give you the case in point that I'm thinking of here is that there was a safety case where somebody put forward that they'd done robustness testing on their software. And in the safety case, it said, yeah, we've done all this robustness testing, everything's great. And the duty holder, the person holding the risk was saying, yeah, we've got a really robust system. And then the system actually kept on falling over. So me, as the regulator, I said, well, you're doing all this robustness testing. Why are you still having all these robustness issues? So I looked at what they'd done and their processes and actually said, looking at it in depth, I see that your interpretation of robustness testing is not really a industry accepted interpretation of robustness testing. So we had a big old argument about these things, as you do. So they brought in an independent reviewer and they said, well, actually, that's right. The testing is not actually testing the robustness of the system. And so when they went back and did more testing that actually tested the robustness, they found the weaknesses in the system. So you need to be very, very careful about the kinds of things that you claim that you're doing. And that kind of goes on to the AI thing. So there's a lot of what you might think of as overloading of terms in AI. And so when somebody says they're doing AI robustness testing, what are they actually mean? What are they actually testing? And how much confidence can they gain from that? Is that okay, Chad? Do you want more? I can talk all day about it.
Thank you, Al. That was great. I'm going to go through the rest of the panel, and then we'll send you some questions from the audience. So, Josh, the AI systems we're designing all interact with humans at the moment. Fitz wrote in 1951 about task assignment in designing human-machine systems. He wrote in the context of automating air traffic control. How far have we advanced in the 70 years since Fitz wrote that?
I think the mensurated answer that Chad GPT will give you will account for degree programs, graduates, journals, publications, impact factors, and show the growth of the field as evidence that we've come a long way. But I think the systems that we interact with, their digitization, are increasingly complex, as is their penetration in everyday life. So I think it's really a question of how far behind the ball we are, because the test community is driven by different market forces than the innovation community. And we're on a Vespa behind a Hyperloop. Usually we come into play after technology has reached a point of maturity or adoption where it's widespread enough to be a potential concern.
After the Teslas are on the road, then we worry about how the drivers interact.
Yes, then we worry about the fires. Right. So I think it's silly to say that we can understand ourselves well enough to forecast how we will interface with technology ahead of that curve. But we are, I would say the more important point is that I think we're hopelessly outgunned in our tool set and methodology to address some of these kind of inflection points that we find ourselves with. Models that have been around for a long time, but are now wrapped in this very, very nice and palatable chat interface that make them very accessible.
Very, very nice conversations with a lot of questions about the internals. John, over to you. AI assurance cases help provide users and organizations justified confidence that the system will work. But, and as Al pointed out, a safety case doesn't make things safe. Charles Perrow asserts that in complex systems, accidents are inevitable. How can an organization prepare for an incident that is inevitable, that involves an AI-enabled system?
Thank you for the topic there. I am serving as the advocate of kind of the operation teams out there. A lot of experience in that area. Incidents will happen. My experience is they happen on holidays, weekends, and in the middle of the night. So let's step back and let's just envision that it's Monday morning. We're pulled into our leadership's office, and we just spent the whole weekend working an incident with the teams. Okay? So now we got to go and think about the after action. Okay? So that's the setting. So I wanted to tee up a couple areas that we can think about as we approach that, and hopefully be a little proactive as this thing of AI starts to come into our systems and into our organizations and such. So the first point, I'm a big believer in integrated operations. So you shouldn't have a dedicated group working by themselves solving AI-type problems, AI incidents. Okay. Oh, and when I say incidents, these aren't necessarily security incidents, availability incidents. These could be performance, prediction performance incidents that we're managing depending on the business, the use case, et cetera. Okay. So integrated operations, as we know, operations teams, they're spread across many different technologies that they have to manage, especially in the middle of the night. Okay. So you need to know how to communicate and work with your counterparts. Number two is the workforce development. So you need to be making sure that your operators are prepared to address what they may face. They have to have some understanding of the system, some understanding of this new technology that we're starting to bring out into operations. The third one, and the leadership piece, the workforce piece, there's operation component and there's a leadership component. And I'm becoming very fascinated on the leadership component because I was faced on making some tough decisions in the past. Okay, so the leaders cannot delegate the responsibility, especially in the AI space. There are nuances to this technology, these solutions, that they have to be prepared to address to govern, provide the oversight. So they need to be prepared, and my sense is leaders are very busy as is. So now they have to take on this additional responsibility. Next point is the data. This is data work, so obviously we're going to talk about data. So the person at the terminal needs access to data that they can use to do fault isolation, to understand what's happening, to be able to do their job. So this is what gets into observability. How do you trace back and be able to find out kind of, how the system operated? Do you have the information to do that? And then what metrics are available for them to use to, again, start to understand and hopefully resolve the issue. And then lastly, and then I'll turn it back over to you, there needs to be some type of lever that you can pull to say, turn off the AI, let's cut back to a human process or a traditional system capability because something's broken, we're not sure what it is. So back to you.
Thank you, John. I'm going to throw a question up to ChatGPT if you throw my screen up. And while we're doing that, would you, the next thing up is questions from the audience. So if we could start moving mics around. So ChatGPT, are we up? Oh, I lost the sharing. That's not ChatGPT's problem, that's my problem. All right, am I sharing? So I'm asking ChatGPT to write an assurance case for itself. So we have a claim, we have justification. ChatGPT says it's accurate and helpful.
It is helpful.
Tested with rigorous methods.
Yeah, I like that.
Excellent.
It hits all of the buzzwords: explainability, data quality.
Wonderful. Thank you, ChatGPT. Questions from the floor?
Hi, good morning. Thank you so much for taking the time. So I would love to hear your thoughts on explainability in terms of architectures or methods to pull out explainability and put that into the model, right? Like having certain layers that do certain things. And I ask because our friend here, ChatGPT, has 175 billion, trained parameters. And as a developer, as a performer, right, my goal is to optimize accuracy, which may sometimes conflict with explainability. So I'd like to see where you think that balance lies.
Josh, do you want to start with explainability?
Okay. I'll start by reminding you that the people sitting next to you have in the trillions of connections in their brain. There's really no easy answer because the agents you work with on an everyday basis will most likely hallucinate reasons for their own behavior. That's the thing. But from a systems engineering perspective, I would say that this is where I want to highlight workforce development. One of the big shortcomings I think that we have is that the various disciplines that are engaged in test and evaluation are still pretty much siloed, right? Comparing human factors and psychology, I am actually a psychologist by training. We're way better statisticians. But
The best at experimental design.
well, I wasn't going to go there. Where I was going to go is that I didn't have one electrical engineering class ever, even though I was doing time series analysis. Point is, until we get to a lot more integration between those fields, it's going to be difficult to figure out how to engineer a system that is explainable by design. Where to start, I know that's an unsatisfying answer, is that the deeply integrated capabilities underneath existing tools are the ones that are going to be hardest to explain. So simply integrated tools that have a very specific use case in a very specific workflow are probably going to be the most contextually bound and grokkable by the average human being.
Anyone else want to take a shot at explainability?
I don't know if this is a shot at explainability, but I think there are lots of different model structures. There was a question in the previous session about deep neural networks being all that we're using, and there's a lot of different models that fall into the AI bucket right now. And so I am a big fan of triangulation in every way, shape, and form. And so not just relying on single models, but to kind of thinking about how do we design systems to be explainable, that we build in redundancy with multiple model structures, some which are explainable from the start, some which are not explainable from the start, and thinking about these not as one-shot kind of tools, but as an ensemble of kind of capabilities that we bring to the table as we're thinking about future system design, but also then want to highlight that not all models will be explainable from the get-go, and that's a really important part of the T&E process, that we have to learn where models work. We really have to understand that input data. The input data is what the models, for the most part, are learning from, unless we've hard-coded in some other kinds of rules. And so it starts from the input data, that we have to understand what it covers, why it's covering that, and what that means for where we can expect these models to work. But then also how the model is ingesting that, what it's learning from that. And that's going to be an iterative process that we're going to come, as we field things into systems and we put them in operations, there's going to be surprises. And through having these very purposeful, systematic test events, we're going to be better suited to figure out what caused that surprise so that we can do the after action and figure out where we need to go for. So kind of a two-part answer, that we should try and build our system so that they can be explainable with every resource that comes at our disposal. And then also we need to really shake and bake these kinds of algorithms to make sure we understand why they're doing what they're doing.
Thank you.
Can I add to that, Chad? Sorry.
Oh, yes,
being
please, Al.
in the room. Yeah, certainly. So one of the important features about explainability is that we have to remember that there are different stakeholders involved with the use of these types of systems, and we need to think about different ways of explaining. So an operator might need a different type of explainability to a technical expert who's carrying out the assurance, who might need different kinds of explainability to the risk owners. And so I think it's important that as people who design and assure systems, that we make sure that the right type of explainability is available to the right kinds of decision makers. Over.
Thank you, Al. I'm going to pull out my soapbox privilege as moderator here and muddy the waters a lot more, because as Al just said, there's different people that want different kinds of explainability. And one of the problems when you have one word with so many different meanings is that it's hard to unpack it. So I have advocated in other places that what we're looking for is interpretability, that the user should be able to interpret what and why is happening. We're looking for traceability, that after an incident we should be able to trace back how that decision was made. We're looking for testability, because during test we want to sometimes measure or quantify things that aren't necessarily part of tracing and the user might not care about, but we want to be able to evaluate. And that's important because on a tank or an airplane, I can put a sensor box and orange wire out and collect those data. In software, I have to design that in as part of the code from the get-go. I can't bolt that on afterwards. And then one last word, just because we're trying to muddy the water more, it's not clear to me that us humans who offer explanations but often invent them want explainability. I think we want predictability, and that we often confuse predictability with the system responds to my inputs in the way that I was expecting with explainability. So there's my muddy in the water. I'll try not to answer the rest of the questions too.
So I'm a statistician, so I'll say we make much better psychologists than psychologists do. I did find it interesting that we're using ChatGPT as sort of a algorithm throughout this discussion on AI assurance, because it seems to me ChatGPT almost famously is not publishing their architecture. And I just wonder if we can truly have AI assurance when an industry doesn't publish the architecture behind the algorithm that they're using.
Who wants to take that one?
I'm going to say that's probably, we should get used to that being more the norm than the exception, especially unless we fundamentally change, especially in the Department of Defense, unless we fundamentally change how we think about acquiring our systems and acquisition strategies, that we should be ready to not have the underlying architectures, and we need to think about where that line is. Do we need access to the training data? What do we need to understand about the training data? What do we need to understand about the model and how it was built in? But that's not anything new. We have really complex software in our systems today that we don't have access to, and we find ways to figure out whether they are safe, effective, survivable. And so I think I don't know if it comes back to a risk-based argument in my mind. And of course, you can buy down risk by understanding more about the system, understanding more about the models that support that system. But you can also buy down risks in other ways. And so I think that's an important part for the community to be thinking about today. How do we buy down risk in cases when we're not going to have access to the models?
I will foot stomp on your point, Laura, on triangulation, but I'll add that consensus is important, because even requirements for open architecture MOA standards don't get around IP rights. So I think an important thing at the intersection of assurance and acquisitions is avoiding vendor lock. So there are multiple providers, multiple models that you can provide different layers for. The same way we think about sensor data, right?
Yeah, if I can, the acquisition piece of this is very important. I'd also like to highlight the use case specifics. Laurie talked a little bit about the system, understanding what is the purpose of the model, what risk you're accepting. I talked about traceability a little while ago, and traceability means you get a prediction, you know what model actually execute that, and think about a large container cluster. You could have tons of containers running. They may or may not have all the same model actually loaded in there. And then taking the model and being able to trace back and say what data set was used to actually train it. And do you have the contextual information available to know kind of, what environment it was being considered, if you're in a field type application and such. So when you do get into the vendors, and it's a very new vendor community too, so they have a maturing process there. I think that should be part of the acquisition discussions. Who owns the training data? Is it a partnership? What's the methodology for that? And how do you maintain it over time? Everything works great in the first 3 months or whatever, and then people fade away, kind of get repositioned, and that's when your risks and uncertainties start to get introduced. So just offer that.
Can I add as well, Chad,
Yes,
please?
yes, please, Al.
Very, very quickly, because I'm guessing there's people who want to ask questions as well. So I'm going to briefly lean on my experience as aircraft certification. And where we couldn't reach the benchmark for software assurance, we were often asked to put limitations on the use of the aircraft. And so where we don't have access to designs and things like that within these AI-based systems, we have to, understand risk, which is what's just been mentioned, but then understand, okay, so how does that limit the way that we can use the system in an ethical and a way that's societally acceptable? And we're going to have to be brave enough to say, actually, if you're not going to give us the architecture, that's going to limit our confidence, and so therefore we cannot use it on system X, or we have to limit it to instances Y or something like that. But it's about making it meaningful, how that limits the way you can use the system.
Thank you, Al. And I want to foot stomp that we express concerns about black box and AI, but we've had proprietary code in defense acquisition for a very long time where companies won't share all the internals with us. It's a problem, but it's not a new to AI problem. Thank you, Al.
So I have a question from the Zoom audience.
Oh, yes.
They ask, should the DoD wait until we have explainable AI to leverage the capabilities and potentially lose an advantage? Or can we just focus on robust models and try to manage the risk? So that's the main question. And as an entertaining follow-up, perhaps you could ask ChatGPT what its error rate is.
John, can I start you on that one? Yeah, the first one. I'll tee up the second one on ChatGPT.
Can you rephrase? I got caught up in ChatGPT and
So
lost my train of thought
I
there.
think I understand. It's should we wait until the models are explainable,
Yeah.
or should we proceed and manage the risk?
Right. We need to manage risk. I do not believe you can just sit and wait. You're always going to have incidents. You're always going to have issues. So you need the procedures in place. You need the engineering process in place to be able to support that. I'm a huge believer in prototyping and learning, and you only learn by doing. I learned a ton by all the problems I had in the operations center, right? So if you don't have the problems, then you're hurting your learning. And I will say this, I know we talked about kind of neural networks and stuff. There are other models that are easier to explain, right? So there's other architectures and things that you could be doing that give you better explainability and help influence that insurance designation. So it's not like they're all in the same bucket there. So I think we need to be smart about how we approach this, do the proper planning, and move forward with the learning process.
And I've seen some recent research from Cynthia Rudin asserting that most of the challenges that we try and solve with AI right now, there are enough different AI solutions that there exist within that set, simple ones, if you go look for them.
I will disagree and say, yeah, we need AI in the fight now, But of course, I can't just say that without caveat, right? The reality is that if we don't charge headfirst into AI, then we're not going to solve some of the problems that came up in the last round of questions, which is how do I get multiple models engaged in the same activity so that people understand what the limitations of one model are by going through other models. That's a problem in data, and that's still a thing. That's a big problem. So hitting the need for AI will help pace a solution for that problem, and I think that's important. That being said, a lot of AI is used in a variety of different use cases. So, mission critical safety systems, but also where AI is embedded as an augmentation technology in workflows where you have a lot of human decision-making processes. I think you can establish consensus where it sufficiently limits risk.
Yeah, I'm 100% agreement. We can't wait and learn by doing. Because if we don't start trying now, we're just going to be further behind the eight ball. But also one of the things that I would like to see is a little bit more strategic look on the risk versus impact assessment for where AI can have a lot of impact. And there hasn't been nearly enough conversation about using AI in business processes in my mind. It's, not just about the high risk, safety critical kind of elements. Like there's a lot we can do to make people's daily lives better using AI and just generically. And so having some kind of, there are risks, but there are also benefits, and maybe focus on where we can have the most impact in terms of process overall would be a worthwhile discussion to have, because we're not having that discussion so much in how do we improve our document processes. Like, can ChatGPT solve the Department of Defense's document problem as opposed to all this digital engineering stuff? And, what's the trade space there?
Al, did you have anything to add there?
Well, I'm sure that I can't speak for the DoD. That would be entirely inappropriate. But certainly in the UK, our policy is basically to be ambitious but safe and responsible. And so what that means in reality is that we absolutely have to leverage the power that AI provides with us or to us, but we have to do that in an appropriate way. And in fact, what we believe, and this has been kind of borne out in not just in AI, but in traditional type systems, is unless you make the system safe and reliable, then the operators are going to reject them, and we're going to lose that advantage. So actually, in developing assurance, we actually make our human-machine teams more capable and overall maintain our battlefield advantage, or our back-office advantage, if you want to put it that way as well. So yeah, it doesn't have to be one at the cost of the other, I don't think.
I like ambitious but safe and responsible. That's that coalesces that very nicely. Let's go to ChatGPT, and I'll pose this error rate question while we look for the next one from the audience. I love the answer. So I asked Bard similar questions. Bard is Google's large language model, and I asked Bard what metrics it used to evaluate its answers, especially because Bard will provide 3 different answers if you go look and it tells you which one it thought was the best. And the important thing here is not what it answered. The important thing is that on 3 different occasions, it gave me 3 different sets of metrics that it used that overlapped but were not the same. I interpreted this to mean that Bard was really good at giving me an answer that was similar to what I was looking for, but was not telling me the metrics that it used to evaluate itself. There are some math problems when I dug into how it thought those were calculated too that were interesting. Thank you.
So I think this is interesting because there is a very nice OpenAI paper that you would think, well, I guess it hasn't been retrained on it yet because it's been written, and it was, so there's a nice OpenAI paper on assessing the accuracy of ChatGPT using standardized tests, the GRE, LSATs, those kinds of things, as well as comparison to human subject matter experts, as well as comparison to other ML models. And I just thought it was a really nice framework for how do you actually look at the accuracy. And ChatGPT is doing better than probably many of us in this room did on some of our standardized tests.
I did miserably on my writing GRE, but I did not get into a school that cared.
So my question is kind of a general AI question about trusting the thing and like understanding what it's saying. So I'll use GPT for example. Since it's a statistical prediction of the next word, it often puts forth the most common solution, not necessarily the best solution. And so when we're thinking about AI stepping in for critical things like Wargame was mentioned, there may be an education and knowledge gap between the regular user, who may be otherwise very credible, and what the tool actually does. I'm wondering about initiatives to educate regular users before it's like universally implemented, and basically before it starts self-referencing, i.e. putting training on ideas that were AI generated in the first place, and, that's already out in the ecosystem because people trust it.
Since I've been going in-house first, Al, can I toss this one to you first?
Yeah, really kind. Thank you. So it's interesting. As you can see, I'm not in the office today. I'm actually working out on trials. And one of the things that's been notable about the trials that we're running this week, which are AUKUS, so it's UK, US, and Australia, is the number of PhDs that are working on that trial is actually quite incredible. And what we finding is that working with AI is really hard. And obviously, we can't expect all our operators to be educated to that kind of level. So I think what we've got to do is we've got to, again, going back to my point earlier on about the different stakeholders and the different needs, people need to be trained to the level that they need to fulfill their task or their role. And I think that if we make user interfaces appropriate, then operators only need to know enough about what is happening at the user interface. They don't need to know all the complex math that sits in the background that's underpinning the models that they're using. Over.
How many PhDs know whether their car has fuel injection or a carburetor? I'll bet all the ones with a carburetor know that.
Fuel injection, I think.
Anyone up here with a...
I think it's a great question, and really speaks to the importance of the data that our AI is trained on. It is learning patterns from data that have occurred in the past, and all that data occurred in the past comes with all the greatness of the information, but also the biases and things that maybe we don't want to preserve that occurred in the past. And so having kind of laser focus on data quality, and more data is not necessarily better. Data is a really important lens for us to take. And so having, I don't know that takes, that Christine Fox made the point on, really understanding data quality, and that is an important piece of this. I think that is something we cannot lose perspective of, and that there should be very purposeful thinking about what we train our AI algorithms on, because it will capture those trends from past data very well. Also want to kind of echo the concept of lowering barriers to entry. There's a lot right now that's kind of, unique tooling, and, everyone's got their favorite, architecture and stack. And so trying to bring that down so that academic disciplines from across every field can start to play with this and bring different perspectives, bring different lenses on ethics, on whether it should be trusted, is something really kind of core to what I've been focusing on, and doing that with our undergrads across all the departments at Virginia Tech. So having these experiential learning modules where academic disciplines from kind of across the university can come in and start playing with it. And I think ChatGPT has done it better than anyone else, unfortunately, right now. But we can put that as something to strive towards, and how, as we think about training new algorithms, let's just go do it, and then let's try and poke holes in them and see where they fail. But we need to lower the barriers to entry, and not everyone needs to be coding at the command line to do that.
Josh, you've done some tests where you've evaluated trust and the impact of trust on user interaction. Can you talk to any of those?
In God we trust, all others we monitor. That's correct. And it's a good platform model. Yeah. I think we talk a lot about trust, and I think trust is I I think what we're really trying to talk about is understandability and interpretability of what we're trying to communicate to end users about risk, and that comes from the way that the technology meets the person and their ability to explore and experiment and receive that feedback. But I think, as a whole, we have to recognize that the issue with trust is that it is a bias. And this is one of the reasons we said we needed AI 5 years ago, is to mitigate our biases. And now we find that it's just as biased as we are. But we want to trust it as a perfect system. And so I think there really has to be a moment when we realize that trust in AI is probably a commodity that we'll never have and shouldn't want to have. And we should have a case-building exercise to establish criteria on which something is trustworthy. Then ultimately it is on the end user or the community or the policies or TTPs on how to trust that thing. So again, in God we trust, all others we monitor and collect data from.
Thank you, and thank you for pointing out the we don't want to trust. And I see sometimes that we say we want to build trust, and there's been some great research here at IDA about measuring trust and about trust as a predictor of use in the construct of the human using the system. But adjacent to that is the idea that you don't want to create trust. You want to create calibrated trust so that the user uses it when it is useful and does not use it when it is not useful. We have another question.
Hi. So since we're talking about AI systems in a military context, or at least for part of this, when we look back at military history, we have a tradition of constantly fighting the last war, right? Of building systems to solve problems that we've already, fought in combat, and we're constantly being surprised, either strategically or tactically, by what the enemy does in the next conflict. So given that sort of context, what are your thoughts on how we can make AI trustworthy and assured, given that we have a thinking adversary who is intending to surprise us and is intending to conceal, how they're going to operate in the future, if that makes sense?
Yeah. John, I'm going to toss this to you because this echoes a lot software security, I think.
Right, and I'd like to bring up the system engineering side of this because we're not going to get the level of trust in a specific AI component that we probably would like to see. And again, we don't want to hold back on that. If you design a system such that there's other controls in place to help mitigate some uncertainty, so let's say you have a governor on, a portion of a predictor. So if it comes in out of thresholds, the governor can then regulate that result to bring it back within means, and the system can handle it. So if you're talking about a vehicle, a drone, land-based, aerial-based, whatever the case may be, right? You want to design the system to be able to address that. You can still realize some of the really advanced capabilities and the processing capabilities that an AI component may have, computer vision, for example. But you're able to go ahead and make sure that the system overall is an acceptable level of trust and meets your needs, in essence, to be able to move forward on. So,
John, how does this change with the thinking adversary part? That we're not just building Netflix, we're building Netflix while somebody's trying to steal our movies.
So the whole adversarial machine learning piece gets into a whole nother kind of side of this and dimension to this. And that gets into somewhat of your engineering process, your data controls, and all those type of things. The importance of protecting your data, now that you're talking about building, training AI models, it is so significant there. you need to make sure you have data integrity. You make sure you have controls in place to restrict access to the data. And then when the models are produced, you can put them hopefully in a registry somewhere, and they're managed. And you need to make sure all the controls are in place for the models themselves, because they're somewhat a processing unit. They're also somewhat a piece of data. So there's that whole kind of systems management, like you said, software engineering piece of this that we need to make sure that, you know, our adversaries are not able to compromise our own development process, in essence, and then our capabilities in the field. Does that help?
Thank you. Thank you. Other panelists? Or we can find another good.
I'll just foot stomp the data security piece being critical, coming back to the question that we got earlier, too, about these, you know, how are we making sure that we're not introducing faults into our models through the data itself, but also kind of new concepts of data monitoring, that we need to have kind of active monitors on our data, not just securing it, but understanding if it has been changed. That's a really important part. And I don't know if I'm not a military historian or expert in any way, but I think in terms of fighting the past wars, I think what we're all seeing right now is that there is a very competitive environment in the data space and the misinformation and disinformation space. And so being able to secure our information, data, models, all of the above that Don just hit, is a critical part to, well, not a war, the current contested environment that we live in right now. And so I don't know if I think we're actually, you know, right in the thick of making sure that that happens, so that we can do things like diagnose misinformation, disinformation. That also comes back to the point of triangulation and critical thinking, that we need to have, you know, multiple data streams, multiple sources of information right now to make sure that we understand what reality is.
So can I add something?
Yes, please.
Is that okay? So I'm going to say something that's very much our bank's opinion and definitely not MOD policy here, because I'm not in a position to do that in this area. But in response to the original question, I think what we need to do is we need to absolutely recognise that our adversaries won't necessarily have the same ethical or legal standards that we hold ourselves to. And so in preparation for fighting against those adversaries, what we need to do is we need to red team or prepare our red teams that can operate in those ways in which we wouldn't operate. So we need to generate our wargaming red teams to fight in such a way that we would expect the adversary to fight rather than how we will fight. Over.
Thank you, Al. And we have one question here, and we just have a few minutes, so this is the last question, right?
All right, thank you. Hi. So I'm relatively fresh out of grad school, and there's a lot of other students here in the crowd who've also taken a lot of machine learning coursework. But a lot of what you guys talked about today kind of went way over my head. So I guess my question for you all is, what do you think are the skill sets or competencies that should be common denominators among all people working in the AI assurance arena?
I'm going to take this one really quickly and say that I was at a workshop a couple months ago where a bunch of amazingly smart people were sitting around talking about how at the international level we can keep AI from starting the next war. And not a single one of them had data science or machine learning backgrounds, because those didn't exist when that level of people showed up. So we had actually representatives from OpenAI and a couple other corporations, a couple folks from DoD and DoD adjacent, and the only people there that had actually done AI with their fingers were the grad students that were sitting in the room taking notes. So one of the answers to that is, I don't know. But I'll pass that to...
Critical thinking and the ability to interrogate data and data literacy. Those are my top ones. Sorry, that was a quick answer.
Controls and systems engineering. Second, start working with data that you didn't create, collect, or that no one else has cleaned. Using other people's data to do that stuff we'll show you what a real pipeline looks like.
I like Josh's answer. He did good. Took some of my words there. I would say it's good for lay people to have a basic understanding of how to build a model, how that works, the nuances there. They don't have to understand all the math and all the nuances there. You can understand the core process, but then I like when it said about the software development process, the system process, to say, okay, how do you manage an overall system at the production level? Like, what are the pieces of that you need to appreciate, because you're just fitting in an AI piece into the larger system engineering process. So,
Al, your thoughts?
Yeah, so I very much liked Laura's opening piece there about the need to be self-critical. And a number of times I see machine learning research where the researchers just basically conduct their own tests which confirm what it is that they're trying to argue or trying to put forward, rather than trying to undermine their own work. And so what we should be doing is we should be making sure that as we learn to develop systems, we learn how to test them in a meaningful way, so that we can make sure that we're not all turning into snake oil salesmen.
Thank you, Al. And I do believe we are in our last minute, so I just want to say thank you. Thank you to DataWorks. Thank you to this panel. Thank you to Al for joining us from across the pond. I enjoyed it, and this was the panel that I put together because this is who I wanted to hear from. So thank you.
Chad, I would like to know if ChatGPT has heard of DataWorks. While Chad's looking that up, okay.
Not a conference, it's a workshop.
So my guess is there's another DataWorks that we're going to get.
Yeah.
Oh, we missed that. Wow. No.
All right, well, another round of applause for our panel.